Hey folks, Andy here. I'm here at my screen, and well, this is actually the morning after I was playtesting last night at 1 a.m. and I was thinking about the game, and I had a little bit of time at work today, so I thought I'd just work on some simulation. So I'm working on this combat mechanic for this nano game, and I want it to be a little bit like the game Mini Rogue, which is really actually Mini Rogue. Kind of their combat mechanic is actually very similar to a lot of other combat mechanics I've seen other places, but which is kind of why I like it, is that it's a good distillation of that. But anyway, and there are a couple of things I want to change and kind of do my own way. But as I was thinking about it, as the mathematician in me really wants to understand the probabilities, and I want to understand how much certain choices you make in the game affect your combat chances. And part of this is that I want the game to be about ingenuity and not about die rolling. And one thing that I like about roguelikes in general is that there is that element of chance, and that's exciting. But I think it gets to be too much if it's all about just waiting for a good critical hit. And so I want to, test that out. So what I've done is I've written up some Ruby here. Now, none of this is Squib stuff. So if you're new to programming, you can try to do this kind of thing, but this is really more me being a programmer here. I'm doing some advanced stuff, so don't feel like you have to do this for Squib. But I thought I would just show it to you because this is a vlog and that's what we're doing. So what I did is I actually implemented the combat system in Ruby. Here it is, right here on the left here, and so what I do is I have a random number generator that comes in. I can actually seed the random number generator with any number that I want. I roll a die, and then the way the combat system works in this game, at least that I currently have in my mind, is exploding dice with a miss. So when you roll a 1, that's a miss. When you roll a 2 through 5, that's just what you get in terms of your damage when you're fighting a monster. And then when you roll a 6, that's a critical hit. And then a critical hit, it means that you get the choice of rolling again and then adding that to your previous thing. It's called exploding dice, very common mechanic. It adds some interesting choice in combat. A lot of times the choices are obvious. If you've already defeated the monster, then just quit while you're ahead. I actually did build that in here, so if you've already won, so I keep track of the monster's hit points. If the hit points are 5 and I've rolled a 6, don't even bother. You've already defeated them. Why keep going? So I built that into the simulation a little bit to make it a little bit more realistic. I am not implementing any kind of strategy other than the obvious choices like that. I'm not implementing aggressive versus conservative kinds of strategies. I don't want to do too much simulation here. I just want to kind of look at the possibilities. And really, I want to look at, what if somebody was not trying to be really ingenious with their building of stuff, and they just fought every monster they could and tried to win. So they just tried to win with dice. And what I want to do is I want to limit that. I want that super hyper aggressive player who doesn't care about the mechanics of rebuilding scrap. I want them to lose, maybe lose 99% of the time, maybe 1% of the time, but nobody's really willing to play any game that you only win 1% of the time. So that's kind of the idea. And then if I can make a game that hyper-aggressive player wins like 1% of the time, but then if you play it smart, you can still win, then that's the kind of game that I want. So I'm going to build kind of the numbers around that. That's my thinking. So anyway, so here I have the attack kind of all implemented with some obvious choices built in, but no real strategy. And then what I did is here's a little bit of a programming lesson. I used test-driven development over here. So test-driven development is where you write tests and then you implement your code to match the tests. So I actually wrote this combat spec first. And so what I would do is I would say, okay, if you roll a miss, then you should get 0. If you roll a 2, then you should get 2, and so on. And then you can see I don't really have any tests other than the regular 2 through 5. But then if I have a test for then I have various tests for critical hits, and then of course quitting while you're ahead. So I kind of try to exercise all of the paths through my code. yeah, my code is recursive. You can see that attack calls attack. So again, this is advanced programming stuff. If you're not into that, or you're just learning Ruby, this is definitely the kind of thing that college students would do in their first 2 years of a college degree in computer science. So if you want to go to that level, absolutely do it. It's awesome. But if you're not, if all you want to do is make components, then you don't need to do any of this. So, okay, so we've got crits, quit while ahead. I've tested all of that. So this is how I'm confident that my code actually works, is that the die roll actually works. Another interesting thing is that in here I use RSpec. That's the tool that I use. And then I also used RSpec's mock objects. And I love how RSpec does mock objects. It's super easy. Basically what I'm saying is I take the randomness out, and I say what the die roll is going to be. And so what I do is I create a double. I create a double random number generator, which is it's like a stunt double or a mock object. And I say what it's going to roll every time. So I control the conditions. Rerunning my tests is not going to be different every time I rerun them. So, and then the second method that I wrote is down here. This is these are the win conditions. So this is the actual combat system. You can see that there are some times where I used the debugger here, the bybug debugger. If you want to win, given my hit points, my attack, the creature hit point, the creature attack. So the way the combat system works is I come up with my hit. I do my hit. If I rolled a miss, which is 0, so even if you get crits and crits and crits, and then you get a roll of 0, it all goes down to 0, which is kind of what makes the choice interesting. Assuming it wasn't a miss, I also add my attack stat. So I'm not doing multiple dice. I'm just doing one die, 1d6. But the attack mechanic is basically a number that gets added to the die roll at the end, if it's not a miss. And so that's kind of the thing, is that if you miss, you miss. Doesn't matter how good of an attacker you were, you missed. So there's always the possibility of losing, which, I don't know how much I like that, but okay. Well, you do have insta-slaughter with the items, so maybe that's okay. And then once you get your hit, you add your attack. If it wasn't a miss, you subtract it from the creature. If the creature's hit points are now down to 0, you win. Otherwise, the creature attacks you for a fixed number every single time. Yeah, I know in more complex systems, the creature's attacks is randomized as well. But again, this is a nano game. I want to do this with like one die. So I don't want to do any more dice than that, or at least not now. And then again, we just keep going. And then if I don't win, then we return false. That's the combat system. So nice and simple. I also feel like, if my code can be simple to implement the combat system, then the rules of the game will be nice and simple. And so that's another kind of metric that I have. So that's why I like doing simulation, at least when the mechanics are simple like this. I have tests over here. Okay. And then what I do is I put all of this in the lib folder. I'm actually going to be organizing my Squib stuff into a little bit more. As you can see, my Project Boltrets folder is getting lots of different kinds of files, and so I'm going to start organizing these into folders in a moment, or in a little bit. But I run all of this in a separate script called Sim Combat. And Sim Combat over here is what it does is it runs a lot of simulations, because it's doing 1 to 15 of my hit points. It's doing 0 up to 4, 1 to 15 for creature hit points, 1 to 4 creature attack. So it's doing every combination of all of those, and then within each one of those combinations, it's doing 1,000 fights. And here I have the same random number generator. I could have it be based on the time, but just to make things a little easier. And then I calculate the win percentages. And so when I run it, it just looks like this. And I put this into my rake file, so all I do is just rake sim. It takes, a couple of seconds, not very long. I suppose I could do 10,000 if I wanted to, but really I think 1,000 is plenty fine. That exercises plenty of the paths. It wrote everything out to a file. Here's my file, combatsimresults.csv. And let me show you how I do this in Excel. So here are just some Excel things that you can use. So this is a CSV. I mean, I could actually have it output to an Excel. So I have to redo this every time I rerun the simulation. Not ideal, but whatever. So first I'm going to make this bold, and then I'm going to do freeze panes to freeze the top row. And then I like to use colors, so I'm going to go to home here, and I'm going to put colors, and I'm going to have it be, kind of traffic colors for the win percentages. I don't know. I probably could modify this a little bit. I think an 80% win percentage is actually, probably should be green, but whatever. I'm going to have my hit points be, I'm going to do also conditional formatting, just put a color scale on that. So as you can see, well, I'll do it on the creature hit points. So you can see hit points, I'm going to color it the same way because hit points are hit points. So you can see that my colors, I can kind of visually see quickly what my colors are going to be. And then when you structure your CSV this way, at first I wanted to make it like a giant table, but then I realized that I have 4 dimensions. So that's a 4-dimensional table, and I only live in a 3-dimensional world, so I can't do that as easily. So at that point, you're talking filters. So this is a feature that it's underused in Excel. I know the people who I know about this feature use it all the time. So it's great for handling tons of data. So let's filter the data. So you go to the data, click on filter, and let's resize these so that we can actually see what's going on. I can increase my font a little bit. So at this point, maybe I have thousands of rows in this thing. I have, I guess, 4,500 rows here. And so whenever you have lots of data, I know this from research, whenever you have lots of data, you can kind of peruse it, sure, but you'll actually get a lot more information if you have specific questions that you want to ask. So I can actually go and look up in my Excel sheet, in my game data, what I actually did. I didn't put a lot of thought into my game data, but suppose I'm thinking, okay, how much does one attack give me? And suppose this is kind of a normal situation where I've got maybe 12 hit points, and the creature I'm attacking maybe also has 12 hit points. So it's like an evenly matched battle. How much does his attack matter, and then how much does my attack matter? So as you can see here, that in situations where I have where it's 12 on 12, and remember, I'm going to be fighting multiple monsters, so 12 on 12 is actually, the odds are stacked against me. But if my attack is even if my attack is 0, his attack would have to be 3 or 4 in order for me to really lose. Most of the time, if he has an attack of 2, having a hit point of 12 and an attack of 2 is really not that much. He's not going to be able to plink me that much. But if he has an attack of 4, that's pretty deadly. So suppose he had an attack of 4. How much does an attack help me? Well, it's so say now, let's say my creature is going to be an attack of 4. Well, if me having an attack going from 0, 1, 2, 3, 4 is huge, right? I mean, that is a massive increase. And so getting that first attack is really key. And really for games like this, what I'm looking for is the desire to get everything at the beginning. So you're going to want to increase your carrying capacity. You're going to want to increase your attack. You're going to want to increase your hit points. And so you have to really make some hard choices about, do I increase my carrying capacity or do I increase my attack? Am I a collector? Am I an attacker? And that really creates different kinds of strategies. So I really like this. I think this is a really nice way. Again, this simulation kind of represents a hyper aggressive way of playing, but I think it's a really good upper bound. So if I can make a game that is really hard if you just relied on the dice, but is definitely beatable if you are smart about how you manage your resources, that's the game that I'm looking for. So there you go. Cool little simulation. Really didn't take me that long. It probably took me, it's about 2 hours to build all of this really from scratch. I'm going to push all this to the repo. Feel free to use it, borrow it, whatever you want to do. This one was a little bit longer than my usual vlogs, but I hope that this was informative. And it's also nice. Thank you for just listening to me process this. It's nice for me to just verbally process my choices. So, all right, have a nice day.